Welcome to my new calculus channel. My name is John Gabriel, and today we're going to be talking about propositions 4 through 6 of the most important book in the elements, which is book 5 on ratio and proportion. So let's begin. Now, what we're looking at here is the road to arithmetic, okay, which we still have a long way to go because we only introduced number in book 7, but all the arithmetic operations are established in book 5 and proposition 12, and after this video we'll be halfway to proposition 12. So the four operations are what we're heading towards in proposition 12. Let's go over these propositions quickly. So proposition 4 is simply the general case of the previous proposition, which is proposition 3. And again, you know, in Greek, when you want to see what is actually being said, rather than looking at Heath's remarks, is you read what Euclid states when he says, I say, okay? So he says, I say that E is to B as F is to D. Now, I've actually simplified this because in the original, it's not exactly the way that it is stated in proposition 4. But I've done that because these are just random multiples of, higher random multiples of the ones that are stated in the proposition that Euclid has in his elements. So it says that if A is in proportion to B, and in proportion to C, which is in proportion to D, then any multiples E and F of B and D respectively imply that EF, the ratio EF, is proportional to the ratio BD. And I've already covered that in proposition 3. Okay, so in other words, over here, I've covered that in proposition 3, and you've got these notes in the details section of the previous video. I shall also provide these notes to you in the details section of this video, so no need to worry about that right now. So taking greater random multiples of B and D is the opposite of the Euclidean algorithm, which one finds in book 7 and proposition 2, where the divisors are used to reduce the multiples to the greatest common measure or divisor, meaning that one can start with some random multiples E and F and then proceed to find B, the ratio BD. Okay, so that's what proposition 4 deals with. And then proposition 5 is not exactly what Heath is saying, because Heath's remark is an overgeneralization. So again, we need to look at what Euclid says in the Greek, and this is what he says in the Greek, and he says basically, I say that the remainder EB is also the same multiple of the remainder FD that the whole AB is of the whole CD. And this is pretty easy again to prove. So if AB is the multiple M of CD and A is the multiple M of CF, then, and this is what follows from this I say, EB is a multiple of FD, okay? So, and the proof, well, since AB is equal to AE plus EB, AB is equal to AE plus EB, which is given equal to MCD, it implies and is implied by this, meaning that AE plus EB is a multiple of CF plus FD, because CD is CF plus FD, right? But we already know that AE is a multiple of CF here, it was given. And so what's left on the right-hand side for EB, what's left on the right-hand side for EB is M times FD, or M is a multiple of FD, which is what was required to prove. And that handles proposition 5. And proposition 6 is really just a special case of proposition 5, whereby FD and EB are the same multiples of a magnitude, or themselves equal. So this is equivalent to Heath's remark, where he states that compared with this, right? So in this case here, in this case here, it deals with the same magnitude and not different magnitudes A, B. So by this stage, the concept of multiple is firmly established, even though the concept of number has to be introduced in Book 7. And of course, Book 6 further demonstrates these propositions through geometry and the use of magnitudes only. Now, the Greek word πολλαπλάσια means multiple, and the word for multiplication, which is derived from the word multiple, is πολλαπλασιασμός, okay, which means before Book 7, it's not formally defined for numbers, only for magnitudes, as we shall see shortly in the upcoming videos. So the order of arithmetic operations becomes apparent as one works one's way through these propositions. The most primitive operator is the difference or subtraction, followed by sum or addition. And of course, division, which is defined in terms of difference and sum, is next, and finally multiplication is defined in terms of division. What does this all mean? It means that there's a general definition of arithmetic operations for all numbers, as you shall see. Okay, now the general definition doesn't define 2 times 3 any differently to 3/5 times 2 9ths. Okay, so for example, you're taught at schools that this you can read as 3/5 of 2 9ths, and this as 2 groups of 3. So there's a slight difference in the way you understand the operation, but that's not the case. They're defined in exactly the same way, and you will see the beautiful definitions as we approach Proposition 12. So I'm going to stop here, and hopefully you'll join me again in the near future. If you're not already a subscriber, become a subscriber on my channel. Click like, spread the news of this channel, and I'll be in touch with you again soon. My name is John Gabriel. This is a new calculus channel. Till next time, goodbye.